This question belongs to the topic design of machine elements from the topic subtopic riveted plates. Okay, here is the question. Consider a schematic. Consider the schematic of the riveted lap joint subjected to tensile load F as shown below. Let D be the diameter of the rivets and SF be the maximum permissible tensile stress in the plates. What would be the minimum value of the thickness of the plates to guard against the tensile failure of the plates? Assume that the plates to be identical. Okay, so here is the two plates riveted together and subjected to tensile force F is asking you to compute the minimum thickness of the plate. So now the critical section of the plate will be this one. Okay, so from here the failure has to commence. The entire width of the plate is given as W. This is given as W. This will be W, and this will be D, and this will be D. So the net width will be, that is width of the plate will be W minus 2D, okay, into thickness into the permissible stress, that is SF, is equals to applied force F. So T is equals to F by W minus 2D, width minus 2D times of SF. Okay, so which is matching with option A. This is the end of the answer. This question belongs to the topic design of machine elements from the subtopic theories of failure. In a metal forming operation, when the material just started yielding, the principal stresses are sigma 1 equal to 180 megapascal and sigma 2 equal to minus 100 megapascal. Sigma 3 is equals to 0. The following von Mises criteria, the yield stress is dash. Okay, so this is a direct and straightforward formula based question. So here sigma yt square is equals to 1 by 2 times of sigma 1 minus sigma 2 whole square plus sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square. Okay, so all the values are given to you, that is sigma 1 is equal to 180 megapascal, sigma 2 is equals to minus 100 megapascal, sigma 3 is definitely 0, so this will be sigma yt square is equals to 1 by 2 times of sigma yt square is equals to 1 by 2 times of 180 minus 100 is plus 100 whole square. This will be minus 100 whole square, this will be minus 180 whole square. Okay, upon solving this entire expression you will get sigma yt is equals to 245.76 megapascal. Okay, this is the end of the answer. This question belongs to the topic design of machine elements from the subtopic variable loading. A machine element has an ultimate strength sigma u of 600 Newton per mm square and endurance limit of 250 Newton per mm square. The fatigue curve for the element on log plot is shown below. If the element is to be designed for a finite life of 10 power 4 cycles or 10,000 cycles, the maximum amplitude of completely reversed operating stress is dash Newton per mm square. Okay, so here he has given the plot to you. In the plot he is depicting that at 0.8 times of when you are stressing the element close to the ultimate strength, or that is 0.8 times of ultimate strength, it is able to sustain a life of 10 power 3 cycles. Okay, and similarly if you are stressing the element up to 250 megapascal, if the stress intensity or the in case of reverse loading pattern, if you are stressing the element to 250, if this height is 250, okay, if this height is 250, then the life of the material is 10 power 6 cycles. Okay, so now that here you are required to calculate if the life is 10 power 4 cycles, okay, 10 power 4 cycles, what is the stress amplitude for this for the element to for the machine element to sustain this many number of cycles. Okay, so now projecting this on the curve, so approximately the value will be in between 0.8 times of sigma ut and sigma e. Okay, so now applying the linear interpolation for this to get the value to get the value of sigma. Okay, let us say this to be as sigma. Okay, so now applying the linear interpolation. Okay, here this is on the log plot, so it has to be this will be the y coordinate, this will be y1 this will be y1 x1 at this point, and it will be y2 x2 at this point. So here it has to be log to the base 10, that is 0.8 times of sigma ut minus log of sigma e divided by log of 10 power 3 minus log of 10 power 6. First I have interpolated these 2 points. First I have written the equation of equation of the slope for these 2 points. Now similarly I will write the equation of slope for these 2 points, that is, this is in some intermediate point. Okay, so this I can write it as log of 0.8 times of sigma u minus log sigma, and this is sustaining a life of 10 power 3 cycles. The component which is the other cycle is 10 power 4. Okay, this is the equation given. I am equating the slopes. Okay, so now here this is sigma ut is given, rest is the substitution work only. So 0.8 times of 600 is 480 log 480 minus log 250, this is 3 minus 6, log to the base 10, that is 10 3 minus 6, and this will be log 480 minus log sigma is equals to 3 minus 4. Okay, so now only that you are required to solve for log sigma. Upon solving for the log sigma, or upon solving for the sigma value, the sigma value will be 386.91 megapascal. Okay, this is the end of the answer.